Okay, so I'm just adding this video to the second video because I think the trick that I gave you, right, when I said that you can use your denominator to scale your x-axis and the numerator to scale your y-axis, doesn't really work well over here. I did that initially using that trick. So the y-axis, you have to be careful with that. The x-axis does, a nice trick for the x-axis is to look at the numerator, which is what we're going to do. But in this case, I think you could scale your y-axis in multiples of 3 using multiples of 3. That it will work, but your graph might not be that precise. So with the y-axis, you have to be careful. Sometimes maybe just scaling it by 1 will make it very precise. Okay, and in this situation, scaling it by 1 maybe might be a best option. So that's why I removed that piece from my previous video, so that you're not getting confused. Okay, so I guess look look at your denominator, and that will tell you how to scale your x-axis. But the numerator may or may not tell you how to scale your y-axis. Okay, that you kind of have to pick intelligently. If it's not working with the numerator, if you're not getting like precise values, then just scale it by 1. Okay, 1 is your best option. Okay, so first thing that you need to do when you have a linear equation, identify the slope. So the slope over here is -3/4. So because, remember, I know it's a fraction, but it's still negative, right? Because it's negative, that means my function will fall, okay, or it will decrease. My b value is equals to 1. So this is my Cartesian plane, right? So this is x, this is y. B value is kind of like my starting point. So I know that I'm going to be at 1 over here. So when my x value is 0, I'm going to be at 1. And now because my slope is negative, I'm actually going to be going downwards, okay? So this is basically what the sketch looks like, okay? And which is pretty, I mean, it gives you a good idea of what the function looks like, but when you're graphing it, you have to be a little bit more precise. So you need to find another point, okay? Another point in the graph. So this is how you would sketch it, but to be more precise, you need another point. So let's find that point. Okay, so how do you find the other point? Because your denominator is 4, pick any multiple of 4. I'm gonna pick the smallest multiple of 4, which is 4, right? So let's do the calculations maybe over here. So when x is equals to 4, let's find out the y value. So y will just equals to -3/4 times 4 plus 1. So the 4s, you see, you will cancel, which is why it makes sense to scale your graph in multiples of 4. So -3 plus 1 is -2. So that means that when my x value is actually equals to, let's say, -4, my y value will be -2. Okay, so again, when you're graphing it, maybe a wiser thing to do would be to plot the points first before you join them. Okay, so what do I mean by that? Hold on, let me fix this. So let me erase this, let me erase that. So this is my point 1, 0, right? So this is my b value. Now let's pick my second point. So at 4, right, this is the point 4 comma -2. And this tells me that my point, starting point, has to be at 0, 1. So this is 0, 1. That means I'm scaling my y's by 1. Okay, so this is 1, this is 2. So this, I guess, is -1. This is -2. And let's say this is 4. Okay, so this is 4. And my second point will be over here. Okay, at 4, I'm going to be at -2. And that is it. Now, all you have to do is just, so if this is 4, right, so that means that this is -4. And then the next one will be -8, and so on and so forth. Again, you can scale this by 1. You can scale everything by 1. But for the x-axis, right, just look at your denominator. Your denominator will tell you how to scale it. For the y-axis, it really depends. Sometimes you could use this 3 scaling, right? You could look at the numerator and then scale it that way. Sometimes it will work, but when it doesn't, then just go back to the basics where you're just increasing your graph by 1. Okay, so 1, 2, 3, and then 4, and so forth. So this is -2, so this would be -3, right? So when you know when you're having a hard time, scale your y's by 1, and this should work. Okay, so now all you have to do is just connect the two dots. Okay, and that is it. Okay, so this is what your function will look like. And yeah, so this is how you graph. But the sketch, I guess, you know, as you saw at the very beginning, right? My sketch kind of gave me an idea of what the graph would look like. But to be more precise, you need 2 points, okay? Um, Thanks to the y-intercept, you already have this 1 point, 0, comma 1. Find the other one. Um, how do you find the other point? Look at your denominator, okay? If your denominator is 4, then you'll have to find multiples of 4. So 4 would be a good candidate, 8 would be a good candidate, -4 would be a good candidate, right? So um, but again, because 8 would be really far away, right? 8 would be somewhere over here. So I don't want to like pick big multiples of 4. So that's why I picked 4, which is like the smallest multiple of 4, okay? And that's one way of graphing it. But yeah, I mean, the sketch tells you what the function will look like. To be more precise, to graph, you kind of need to play around with the scaling and picking nice x values that will give you nice whole numbers, right? Because technically you could pick any x value. I could have chosen x is equals to 1, but then if I plug in 1, then I'm going to have 1 times negative 0.75, which is negative 0.75 plus 1, that's plus 0.25, right? So at 1, I'm like somewhere over here, and that's kind of like hard, right? I'm at the point at 1. If you plug in the value at 1, I'm going to be at the point 0.25. And that's kind of hard to plot, right? That's why I'm asking you to use multiples of 4. I hope this is kind of making sense. If not, then please send me an email. I will also be available um, on Thursday for office hours. And if the homework is giving you a hard time, send me the question numbers, and I can hopefully make another video on Wednesday or something and post that as solutions. You will have the solutions, but if you really want me to break it down, then let me know. But other than that, I think this should be good enough. But please let me know if it's giving you a hard time. And then I will maybe spend more time on this or do it a little differently. Just send me an email to let me know. Okay. Thank you so much, guys. Take care.